Hello everyone, my name is Meah de Saradolla, a third-year Bachelor of Science in Civil Engineering, currently studying at the University of Southern Mindanao. For today's video, we are going to solve 5 problems about the concepts in structural steel design. These are the load combination for allowable strength design and load combination for load and resistance factor design. Problem number 1. A column in the upper story of a building is subjected to a compressive load from the following sources. Dead load is equals to 30.8 kips, occupancy load, leave load is equals to 1.7 kips, roof leave load is equals to 18.7 kips, and snow load is equals to 19.7 kips. The given are: the dead load is 30.8 kips, the leave load is the 1.7 kips, the roof leave load is 18.7 kips, and the snow load is 19.7 kips. Letter A question. If load and resistance factor design is used to determine the factored load, required strength, to be used in the design of the column, which ICSC load combination controls? Based on the given, we can only solve for the combination of 1, 2, and 3. First, we are going to substitute the value to the given combination. The combination 1, 1.4, dead load is equals to 1.4 times 30.8 equals to 43.12 kips. Combination 2, 1.2, dead loads plus 1.6 lead loads plus 0.5 snow load is equals to 1.2 times 30.8 plus 1.6 times 1.7 plus 0.5 times 19.7 is equals to 49.53 kips. For the combination of 3, 1.2 dead loads plus 1.6s plus 0.5l is equals to 1.2 times 30.8 plus 1.6 times 19.7 plus 0.5 times 1.7 is equals to 69.33 kips. Next, the number 2. Letter B. What is the required design strength of the column? Since the design strength is equals to 69.33 kips, we are going to use the formula of factor load is less than or equal to design strength. So the design strength is equals to 69.33 kips. Letter C. What is the required nominal strength of the column for a resistance factor of 0.9? The factor load is equals to 69.33 kips and the resistance factor is equals to 0.9. We are going to use the formula of required nominal strength, where is equal to the design strength all over the resistance factor, and you need only to substitute the value. 69.33 all over 0.90 is equals to the required nominal strength is equals to 77.03 kips. Next, letter D. D. If allowable strength design is used, determine the required load capacity, required strength to be used in the design of the column, which AISC load combination controls. So these are my solutions. For the combination 1, D is equals to 30.8 kips. Combination 2, D plus L equals to 30.8 plus 1.7 kips is equals to 32.5 kips. For the combination 3, D plus S equals to 30.8 plus 19.7 is equals to 50.5 kips. For the combination of 4, D plus 0.75L plus 0.75S is equals to 30.8 plus 0.75 times 1.7 plus 0.75 times 19.7 is equals to 46.85 kips. So, among 4 combinations, the dominant strength or the required strength design, the largest is the combination 3, which is equals to 50.5 kips. Next and the last question for number 1, the letter A. What is the required nominal strength of the column safety factor of 1.67? So we have the required strength is equals to 50.5 kips and the safety factor is equals to 1.67. You only have to substitute its value. 50.5 times 1.67 is equals to 84.34 kips. Next, the number 2. Column is subjected to the following loads. Dead load is equals to 26 kips. Occupancy leave load is equals to 15 kips. Roof leave loads is equals to 5 kips. Snow load is equals to 8 kips. Rain load is equals to 5 kips. And wind load is equals to 8 kips. All loads are compression except for the wind load, which can be either tension or compression. So these are the given. Question number letter A. If load and resistance factor design is used, determine the factor load or the required strength to be used in the design of the column. Which AICS load combination controls? For the combination of 1, these are the formula. 1.4 times D, you only need to substitute its value. 1.4 times 26 equals to 36.4 kips. The same as to combination 2. These are the formula is 1.2 times the dead loads plus 1.6 L plus 0.5 S. You only need to substitute its value and it will be equal to 59.2 kips. For the combination of 3, 1.2 times the dead loads plus 1.6 S plus 0.5 L is equals to 51.5 kips. And for the combination of 4, you only have to substitute its value and it will be equal to 50.7. So among 4 combination, the factor load is among the 4 combination, the larger will be the combination number 2, which are the factor load is equals to 59.2 kips. Next, letter B. What is the required design strength of the column? The factor load is equals to 59.2, so the design strength is equals to 59.2 kips. Next, what is the required nominal strength of the column for a resistance factor of 0.9? The factor load is equals to 59.2 kips and the resistance factor is equals to 0.9. So we only need to substitute its value 59.2 all over 0.990. It will result to the required nominal strength is equals to 65.78 kips. Next, letter D. If allowable strength design is used, determine the required load capacity or the required strength to be used in the design of the column. Which AICS load combination control? For the combination of 1 is equals to 26 kips. Combination 2, D plus L equals to 26.15 equals to 41 kips. You only had to substitute its value. For combination 3, the same. 26 plus 8 is equals to 34 kips. And for the combination of 4, D plus 0.75 L plus 0.75 S equals to 26. The value of D plus 0.75 times 15 plus 0.75 times 8 is equals to 43.25. The combination 5D plus 0.6W is equals to 26.0.6 times 8. It will be equal to 30.8 kips. For the last combination, number 6, D plus 0.75L plus 0.7 times 0.6W plus 0.75S is equals to 46.85. So, among the 6 combination, the largest will be the combination 6A, and it will be equal to 46.85, which is the value of our required strength. Next, letter E. What is the required nominal strength of the column for a safety factor of 1.67? For the design strength, it's equals to 46.85 kips, and the safety factor is equals to 1.67. We only have to use the formula required nominal strength is equals to the design strength times safety factor. We only have to substitute its value, 46.85 times 1.67. So the required nominal strength is equals to 78.24 kips. Next problem, the loads on a roof beam consist of a dead load of 0.2 kips per feet, a roof lead load of 0.13 kips per feet, and a snow load of 0.14 kips per feet. The given RD is equals to 0.2, the LR is equals to 0.13, and the S is equals to 0.14. The question letter A, if load and resistance factor design is used, determine the factored load or the required strength to be used in the design of this beam. Which ASCS load combination controls? For the combination of 1, you only had to substitute the value of D, which it will equal to 0.28 kips per feet. For the combination of 2, 1.2 times D is 0.2 plus 1.6 LR, which LR is equal to 0.13 plus 0.5 times the S is 0.14, it will equal to 0.31 kips per feet. For the combination of 3, 1.2 D, where D is equals to 0.2, you only had to substitute its value, plus 1.6 S plus 0.5 LR equal to 0.46 kips. So among the 3 combination, the largest will be the combination 3, and the factor load is equals to 0.46 kips. Next, letter B. If allowable strength design is used, determine the required load capacity or the required strength to be used in the design of column. Which AICS load combination controls? These are the solutions. For the combination 1, same, the value of D is equals to 0.2 kips per feet. The combination of 3, D plus S is equals to 0.2 plus 0.14, 0.34 kips per feet. And the combination of 4, D plus 0.75 L plus 0.75 S, it will equal to 0.31 kips per feet. And the answer is the combination 3, which equals to 0.34 our design strength. Next number 4, beams will be designed for the roof and floor system of an office building. The loads for this system are as follows. Roof dead load is equals to 30 pounds per square foot, and roof leaf load 20 psf, snow load is equals to 21 psf, and a rain load consisting of 4 inches of water. For the floor, dead load is equals to 62 pound per square foot, and occupancy leave load is equals to 80 pounds per square foot. For letter A question, For each of these systems, determine the required factored load capacity for LRFD, which load combination controls. The roof given is D is equals to 30, LR is equals to 20 PSF, and S is equals to 21 PSF. You only have to substitute its value and times 4 all over 12 times 62.4, it will become to 20.8. For the combination 1, 1.4D is equals to 42 PSF. Combination 2, 1.4 dead load plus 1.6 plus 0.5 snow load is equals to 46.5 pound per square foot, and the combination of 3, 1.2 plus 1.6S is equals to 69.6 PSF, and among the three combination, the combination 3, the factor load is equals to 69.6 pound per square foot. And for the floor given, the D is equals to 62 PSF, the L is equals to 80 PSF, and for the combination of 1.4, substitute its value, the 62 times is equals to 86.8 PSF. For the combination of 2, 1.2 plus 1.6L is equals to 202.4 pounds per square foot. So the answer for the floor combination 2, which consists of 202 pounds per square foot. For the letter B, for each of these systems, determine the required ASD load capacity, which load combination controls. For the roof, given D is equals to 30 PSF, LR is equals to 20 PSF, and S is equals to 21 PSF. For the combination of 1 is equals to 30 PSF, the combination of 3, D, dead load plus no load is equals to 30 plus 21 is equals to 51 per pounds per square foot. The answer is the combination 3, which are the design strength 51 pounds per square foot. For the floor given, D is equals to 62 PSF, L is equals to 80 PSF. Combination 1, D is equals to 62. For the combination 2, D plus L, which D is equals to 62 plus 80 is equals to 142 pounds per square foot. For the combination of 4, D plus 0.75 L, L is equals to 80, so substitute its value and multiply, equals to 122 PSF. So the final answer is the combination 2, which the strength design is equal to the 142 PSF. The next and the last problem. Structural steel buildings frequently are designed with diagonal branching system to resist lateral loads. Horizontal forcing result from wind or earthquake loadings. A certain bracing system is subjected to the following loads. The dead load is equals to 13.3 kips. The occupancy leave load is equals to 6.9 kips, and roof leave load is equals to 1.3 kips. The snow load is equals to 1.3 kips. Load is equals to 150.6 kips, and the earthquake load is equals to 161.1 kips. For the question letter A, determine the required factored load capacity for LRFD load for the LRFD load and resistance factor design, which load combination controls. The given are the D1, the dead load is 13.3 kips, the the leaf load is equals to 6.9 kips, and the roof leaf loads is equals to 1.3 kips. The wind load and the snow load rather is 1.3 kips, and the wind load is equals to 150 kips, and the earthquake load is equals to 161.1 kips. For the solution, the combination 1, the same formula, 1.4, you only have to times to substitute for its given value. The D is equals to 13.3 kips, and it will lead to 18.62 kips. For the combination 2, 1.2 D plus 1.6 L plus 0.5 LR is equals to 1.2 times the value of D is equals to 13.3 plus 1.6, and the value of L is equals to 6.9 plus 0.5, and the value of S and the value of LR is equals to 1.3 kips, and the answer is 27.65. For the combination 3, 1.2D plus 16S, 1.6S plus 0.5W equals to 93.34 kips. And for the combination 4, the 1.2D plus 1.0W plus 0.5L plus 0.5 LR, you only have to substitute again its value, the given value at the upper corner. So it will equal to 170.7 kips. And the last combination, the combination 5, the same process, 1.2D times plus 1.0E plus 0.5L plus 0.2S equals to 180.8 kips. So among the 5 combinations, the largest combination is the combination 5, which equals to the factor load capacity is equals to 180.8 kips. Next, letter B, determine the required ASD or the allowable strength design load capacity which load combination controls. These are the givens. For the combination 1, you only have to substitute again the value of dead loads is equal to 13.3 kips. For the combination 2, dead loads plus live loads is equals to 20.2 kips. Combination 3, dead loads. For the combination 3, dead load plus roof leave load is equals to 14.6 kips. Combination 4, D plus 0.75 L plus 0.75 LR is equals to 19.45 kips. The same as letter combination 5, D plus 0.7 E equals to 126.07 kips. And the combination 6, D plus 0.75 L plus 0.75 plus 0.75 rather plus is equal to 104.03 kips. And among the 6 combination, the answer, the largest combination is 126.07, which are the combination 5, and the value of design strength is 126.07 kips. That's all. Thank you.